All right, continuing on now, we're going to discuss electrolyte solutions, electrolytes, and electrolyte solutions. So let's define the term electrolyte. An electrolyte is a substance that can conduct electricity. When dissolved in water. Some people use the term electrolyte to mean the whole solution, but we'll be a little bit more specific and we'll talk about the electrolytes as being the substances themselves that are in the water that are allowing that solution to conduct electricity. So in order to do this, this solution must contain dissociated ions. Dissociated ions, they can then move around in solution. Why is that? Well, a dissociated ion has a charge on it. So for example, if we look up here, we see dissociated ions. These ions can carry charges. And if they can move around as dissolved ions, then they can carry charge from one side of the solution to the other. In contrast, if I do not have any dissociated ions in solution, then there's nothing to conduct the current. So, we're going to be looking for dissociated ions that can move around in solution. Now, before we go further into what's counted as a strong, weak, or non-electrolyte, let's just make sure that we understand some of the terms that we're using. So I've used the word solute, solvent, and solution before, but I just want to make sure that we understand what we're talking about. A functional definition, a practical definition for these that will allow us to use them without getting too technical about it. A solute is the smaller component in a solution. And that is usually a dissolved solid. A solvent is usually the larger component in a solution. And for our purposes, it is usually a liquid. And of course, there are exceptions to that, but we're not going to deal with the exceptions in this class. And then what is a solution? A solution is a combination of a solute dissolved in a solvent. So a good example of this would be, let's say that you're going to take table salt, sodium chloride, and dissolve it in some water, so you have a saltwater solution. So basically I could write that as NaCl, aqueous, an aqueous solution of sodium chloride. So the solute in this case is the sodium chloride that was dissolved in solution. The solvent is the water that was used to dissolve the sodium chloride. And the solution is the solute dissolved in the solvent. So there's my solute, my solvent, and my solution. So those are just practical definitions that will allow us to get a handle on what I'm talking about when I use these terms. So now, with that in mind, let's talk about what makes something a strong electrolyte, a weak electrolyte, or a non-electrolyte. And as we said above, we have to have dissociated ions in solution so that you can conduct charge from one side of the solution to the other. So the strength of an electrolyte depends on the relative amount of dissociated ions. That are in solution. So if I've got a lot of dissociated ions in solution, it's going to be a strong conductor of electricity or a strong electrolyte. If I've got just a few dissociated ions in solution, it's going to be a weak conductor of electricity. And if I have no dissociated ions in solution, it's not going to conduct electricity at all. So there are certain categories here that qualify as strong electrolytes. What are some categories of compounds that we have discussed that have a lot of dissociated ions in solution? Well, just above, we were talking about soluble ionic compounds, right? So soluble ionic compounds, because they are soluble, they will dissolve and generate a lot of dissociated ions in solution. Another category, well, we've talked about strong and weak acids, and the definition of a strong acid is that they dissociate completely, right? So if you have a strong acid, then you're going to have a lot of dissociated ions in solution. So strong acids. So soluble ionic compounds and strong acids give us strong electrolyte because both of them give us lots of dissociated ions. So with these two in mind, I would like for you to try to complete the rest of this. Which categories or types of compounds are going to be weak electrolytes and which are going to be non-electrolytes? And again, think of the categories of compounds that we've discussed. So go ahead and pause the video and see if you can complete this right here. Okay, coming back from pausing the video, weak electrolytes, that means that I have some dissociated ions in solution, but not many. So I gave you a clue up here. Soluble ionic compounds give us a lot of dissociated ions. But insoluble compounds, remember when we were talking about how insoluble compounds still have some dissociated ions in solution? Because everything is soluble to some degree. So that means that weak electrolytes, because everything will give up some dissociated ions to some degree, an insoluble ionic compound would be one of those compounds. Insoluble ionic compounds, most of it will not dissolve, but a tiny amount will, and that will generate some dissociated ions that can weakly conduct electricity. What's another category here? Well, the clue was up here. Strong acids dissociate completely. Weak acids do not dissociate completely. They dissociate only partially. So weak acids. Weak acids dissociate just a little bit to give me just a few dissociated ions that can then conduct electricity weakly. Well, I've got both types of ionic compounds, soluble and insoluble. I've got both types of acids, strong and weak. What's left? Well, A, acids, B, ionic compounds, and C, covalent compounds. Covalent compounds, because they are not made of ions, then when you dissolve them in water, they will not generate ions. And therefore, without any dissociated ions, they cannot conduct electricity, and therefore they are non-electrolytes, covalent compounds. So let me give you an example of each of these. A strong electrolyte, a soluble ionic compound, sodium chloride. When dissolved in water, it's very soluble, dissociates to give us a lot of dissociated ions, conducts electricity really well. A strong acid, hydrochloric acid. The definition of a strong acid is because it dissociates completely. Weak electrolytes, insoluble ionic compounds. Silver chloride, which generally is insoluble, not soluble in water, so it's not going to generate many dissociated ions, but we know that even insoluble salts will give us some dissociation. And so because there's some dissociation there, it can conduct electricity but weakly. Weak acids, hydrofluoric acid. It's a weak acid. It dissociates only partially. Non-electrolytes. What about sugar? Yes, sugar. Sugar is a covalent compound, and when you dissolve it in water, then it will dissolve, but it will not generate ions, and therefore it cannot conduct electricity. I'd like to take a quick moment to talk about something that's pretty important. What about water itself? What about pure water? Will pure water conduct electricity? In fact, pure water is a non-electrolyte. Pure water will not conduct electricity. But wait, you might say, I've heard all of my life that being around water and electricity is an electrocution hazard. And that's right. Because the water that you and I are around all our lives, whether it's a mud puddle or a swimming pool or the water that comes out of our tap from the faucet, it is not pure. It always has some dissolved impurities in it that can then dissociate and generate dissociated ions to conduct electricity. But if you have pure water, then it is not a conductor of electricity, and so it is considered a non-electrolyte. Pure water will not conduct electricity, but again, you and I almost never encounter pure water. Okay, so that's an example of electrolyte strength. So I've given you 4 practice problems here. What I would like for you to do is I'd like for you to take a look at the compound and decide if it's a strong electrolyte when mixed with water. So imagine that I'm taking this compound, I'm going to put it in water, and then I have to determine if it's a strong electrolyte. And it says, which of the following are strong electrolytes? So we're just going to circle the ones that are strong. Okay? So I'd like for you to pause the video now and see if you can do that. All right, coming back from pausing the video, let's take a look at these compounds and determine if they are strong electrolytes when mixed with water. KBr. This is an ionic compound, metal in the first position, ionic compound. So I have to decide if it's a soluble ionic compound or an insoluble ionic compound. Taking a look at my solubility rules, there it is, group 1A ions are generally soluble. And just so that you see it, group 1A ions do include potassium right there. So potassium bromide is soluble. If it's a soluble ionic compound, then it's going to be a strong electrolyte. Okay. Next, I have barium hydroxide. It's an ionic compound, so I have to decide whether it's going to be soluble. So taking a look at my solubility rules, I'm looking for barium hydroxide. Barium hydroxide, no, 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 no. Hydroxides in the generally insoluble category, but an exception includes the barium salt. So barium salt is soluble. So barium hydroxide is soluble. It's a soluble ionic compound, so it will be a strong electrolyte because it's a soluble ionic compound. Okay. The next one. Well, this is not an ionic compound. It has hydrogen in the first position. Does it look like an acid? Well, it doesn't have an AQ indicator, and I would normally expect AQ for an acid. But look at what it says up here, when mixed with water. So we're going to assume that this is going to be placed in water, and when it's placed in water, it will have an aqueous state indicator. So we are looking at an acid, or what will eventually be an acid, when it's mixed with water. So now what we have to figure out is if this is a strong acid or a weak acid. This is the hypobromite ion, so it must be hypobromous acid. Is hypobromous acid one of our 7 strong acids? No, it's not. So therefore it must be a weak acid. If it's a weak acid, it does not dissociate completely, so it's only going to be a weak electrolyte. So weak acid. This is not a strong electrolyte in water. Last one, HClO3. Looks like an acid, and then when I mix it with water and make it aqueous, it definitely is an acid. This is based on the ClO3 with a minus charge anion. That's the chlorate anion. Chlorate anion would become chloric acid. Is chloric acid one of our 7 strong acids? Yes, it is. So, strong acids dissociate completely to give us a lot of dissociated ions, and therefore, this would be a strong electrolyte. Okay, there's some examples about how to determine whether a compound is a strong, weak, or non-electrolyte when it is mixed in water. Now, very quickly, I just want to review again a couple of quick comments here. We've dealt with these before, but I just want to refresh your memory. Strong acids are acids that dissociate completely into ions in water. Weak acids do not completely dissociate in water. And most weak acids, less than 5% of the acid will dissociate for most weak acids. So again, just to remind us that there are 7 strong acids that we have to memorize, and these are definitely going to be on your next exam. This is a guaranteed exam question. So again, there are 3 acids that are based on halogens, chloride, bromine, and iodide. I'm asking you to include the aqueous state indicator as part of their formulas. I will expect you to be able to know the formulas, and you should be able to name them because you have learned nomenclature. But the question that will be on your exam will be to provide the formulas. So that's what I'm putting up here. In addition to these 3 acids, I have two acids that are based on the nitrate and the sulfate. So that's nitric acid and sulfuric acid. And then I have 2 more acids that are based on the oxyanions of chloride, on the chlorate and the perchlorate ions. So this is chloric acid and perchloric acid. And these 7 formulas are the 7 strong acids that you will be asked for on your next exam.